This tutorial is going to deal with the substitution method for solving systems of linear equations. In our last couple tutorials we looked at the elimination method, and as I said earlier in the tutorials, I'll be using the same type of examples so that you can compare the two methods and how they are used. So just do a brief summary of the substitution method and how it's done. We'll do that first. So the first thing you want to do with the substitution method is you want to isolate one variable in one of the equations. A variable in one of the equations. So what you're doing there is you're probably looking at which of the equations is the easiest to solve for a certain variable. Once you've done that, you substitute, I guess, sub in the result for the variable into the other equation. And solve it, and solve for the variable. Once you've solved it, then you would place your numerical value into one of the equations, and solve for the other variable. Okay, so then you would end up having the values for both of your variables, and of course you could check as well to make sure that you're it makes sense and it works out for you. So what we're going to do is we're going to go back and look at the couple of equations that couple systems of equations that we solved in previous tutorials using the elimination method, and we're going to do the substitution method on them. So I'm just going to flip over here for our examples and check that I center that. All right, and then we'll look at this example where we had x plus 3y equals 6, and we also had 2x minus y is equal to 5. So we've got to choose one of these and solve or isolate, and as you can see in this example, there's a single x and a single negative y here. So we can choose to solve for the x in this top equation rather easily, or possibly the y if you like. There's nothing wrong with solving for the other ones, it just would be a little more difficult because of the coefficients in front of them. So I'm going to solve for x in equation A. So that's my first step here. So obviously I want to subtract 3y from both sides. So I'm going to get x subtract the 3y equals 6 minus 3y. So this becomes the value of x based on that equation. So now we take this value right here and sub it into our second equation. So sub in, or into if you like, sub into the B equation, your answer for x. We'll put answer in quotation marks. So in the B equation, wherever you see x, right here with the 2x, is you want to replace it with this whole expression 6 minus 3y. So what we do is we take B, so that would be 2 times, and it has to all be in brackets, this value here, 6 minus 3y. Close the brackets, and then we move to the next part, minus y equals 5. So that's what we did there. We subbed that in where the x was, this value right there. So then we solve this. So now we'll solve for y. So we multiply this out, 12 minus 6y, subtract y, equals 5. So here we have 12 minus 7y equals 5. And then I have to move the number from this side to this side. So I want to subtract 12 from both sides. So 12 subtract 12 is 0, so we get negative 7y is equal to 5 subtract 12 is negative 7. Divide by negative 7, y is equal to 1. So we solve for y there. So the next step would then be to solve for x using another equation. So solve for x given y. We know that y is now equal to 1. Or we hope so. So I'm going to use equation number A. So x plus 3 times 1 is equal to 6. So x plus 3 is equal to 6. Okay, continuing on, subtract 3 from both sides, x is equal to 3. So my solution then is 3, 1. And we'll do a quick check with equation B. So 2 times 3 minus 1 is equal to 5. 6 subtract 1 is equal to 5. 5 equals 5. So we're good. So that would be a quick demonstration of the substitution method. Now, we also did another example type here as well with the m's and n's. So I'm going to flip over and just do one more sample example here for us in this area. So I'm going to flip this over.